So in Chapter 10, we're going to be looking at math that requires a new notation, something you haven't really seen much of. So that's what this section is about. It's just about learning the new notation that we'll be using in the rest of the sections. So first off, our vocabulary, we're going to talk about sequence. Now, a sequence is pretty simple. It's just a list of numbers. You guys are usually used to seeing these numbers listed in the y-axis. So normally they would be like this on a table. And so instead of doing that, though, we just have them listed out. And what we need to understand is that if we want to talk about these numbers in general, we're going to label them with basically an A, and we're going to say that this one is A sub 1, this one would be A sub 2, this would be A sub 3. So if you're noticing the pattern, we have this little thing called a subscript at the bottom. It's not like an exponent. A lot of people want to think it's an exponent because it's this little number being raised. But it's not like an exponent. It's more like a name tag. And so it's telling you which term are you, which one are you in the sequence of numbers. So A sub 1 is the first one, A sub 2 is the second one, A sub 3 is the third one, A sub 4 is the fourth one. And so a lot of times they ask you to follow this pattern and find A sub 7. So they're just saying find the seventh one. So if this 9 is the fifth one, then we'd find the sixth one and the seventh one, and you just follow your pattern of adding 2 in this case. We also use this notation when we're writing the rules. So if we're talking about a linear equation, we would write y equals 2x plus 1. But we're not going to use x and y anymore. We're going to use this notation with a sub n. And so what we'll write is we'll write a sub n, meaning the general term, whatever term we're looking for, equals, and then one rule might be n plus 4. So then if I want to find a sub 1, is all I have to do is you'll notice that n has now a 1 there, which means now I replace any n with 1. So now I have 1 plus 4, so a sub 1 is 5. And then I could find a sub 2. That means I'm going to plug in a 2 where the n was, and 2 plus 4 is 6. Now we can continue on, and you can do this forever. A sub 3 then would be 3 plus 4, which would give you 7. And so you can come up with your own list of numbers or the sequence and have them like that. Sometimes you have to come up with your own rule. And so what you're going to do is you're going to look at it just like we did with linear and exponential, and we're going to do loop-de to see what's the pattern going on here. And for this one, we are adding 5, and then we are adding 5, and we are adding 5. And since each loop-de is exactly the same, we know that our pattern is going to be adding 5. Now, if you remember with the linear, we would write this equals y equals, and remember the loop-de number goes with the x, so we'd write 5x plus b was our y-intercept, and it looks like our y-intercept would be 10. Unfortunately, that's not quite how it works here. So if you remember, if we look at these in the table, I would have a 10 and a 15 and a 20 and a 25. But remember that 10 is really a sub 1, and 15 is really a sub 2. So if you were looking at a table, this x value would be really 1, 2, 3, and 4. So when I want to find my y-intercept, remember your y-intercept happens when x is 0. And so we have to actually go backwards on our table and go back and say, well, now it's y is 5. Even though we're not going to put a 5 on our sequence. I'm not going to put a 5 here. It still starts at 10. That doesn't change. But we're going to use that to help us, because now I can say that a sub n, instead of a y, we use a sub n equals the loop-de 5, and we're going to take that times n, just like we would x. So now our n is like our x. But then when I add on my y-intercept, I'm not going to put 10 because that really is when x is 1. I'm going to put 5 because you have to go back and get the y-intercept. Now, when you graph these things, so remember when we were graphing linear, we would graph the points. So when x is 1, y is 10. When x is 2, y is 15. When x is 3, y is 20. And then when we were doing linear, we would actually connect these dots. It doesn't happen now because we're not considering anything in between. When we were doing linear, we could have values in between, but when we're doing this, we are just doing the dots, and only those things work. Because you're not going to have a 1.5 term. You're only going to have the first term, second term, third term. So do not connect your dots if you're asked to graph these things. Okay, now our next word is called a series. Now a series is basically when you have the sequence, but you're going to add everything together. So in our last example, we had 10 and then 15 and then 20 and 25 and so on. With the series, you're going to say 10 plus 15 plus 20 plus 25, and in the end, well, you have to stop somewhere, but in the end, then you'll have some kind of answer there. So let's first look at the notation for a series. If you want to tell someone to add everything up, you can use something called the summation notation. It's like this capital E, it's a sigma, and it's a capital E, and whenever you see this symbol in math, it means that you're going to add everything up. And then you have to have a rule. So we just talked in the last page about rules. So let's just say your rule now is going to be a simple n squared. Okay? So now where does it start? Are we going to start with 1, or are we going to start with 4? Are we starting with 6? Or 6, haha. Are we starting with 9? What are we going to start with? And that you're going to be told by the top and the bottom of your sigma notation here. And so this one, we're going to start with n equals 1, and we're going to stop with n equals 8. So now what you're going to do to figure out your answer is you're going to start with the 1, and you're going to plug that 1 in for n. So I have 1 squared. And then because it's a sigma, we'll add the next one. So now I'm going to go to 2, and I plug that in, 2 squared, and add the next one, 3 squared. And I'm going to keep on going in order until I get to 8 squared. Oh, I ran out of room. Let's go plus 8 squared. Okay, and then it's just a matter of doing your math. So 1 plus 4 plus 9 plus 16 plus 25 plus 36, and then you just plug this in on your calculator and get your answer. I'm not going to do that right now, but you guys can all figure out your calculator. Okay, so then let's look at another example. Okay, so let's say you're given the series. So you're told 3 plus 5 plus 7 plus 9 plus 11 plus 13, and you're supposed to write this guy. So the first thing you have to do is figure out your rule. So just like in the last one, we're looking at our loop-d's, and it looks like we're adding 2 every time. So that means I'm going to put 2n plus my y-intercept, but remember this is always going to be starting at 1, so we need to go back 1 loop-d, so I'm going to subtract 2, and I'm going to get to 1, so it'll be plus 1. So then, I'm not done yet though, because I always have to say where do you start and where do you stop. We're starting with n equals 1. Remember that's our first one, is n equals 1, so this would be a sub 1, and then this would be a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. So that means I stop at 6, so I put a 6 on the top. And this would be my equation, or my writing the notation for the series. You'll also note that every once in a while you'll also see that instead of an n they use an I. It's quite common in this notation. So we would go I equals 1 to 6, but then we have to make sure in our formula that we use 2i plus 1. But it really just means the same thing.